Hi folks, this is Bob Cunningham. I'm a technical instructor with Fortinet and a veteran, and I'm here to share with you a few things about interpreting debug statements that will probably be useful to you in your NSE4 exam and in your career. So before we get to debugging, let's talk about sessions, because one of the unique, or at least interesting, characteristics of a next generation firewall is that it doesn't filter traffic on a packet-by-packet basis. Instead, it filters things by sessions. So what do we mean by a session? Well, a session is a computer networking term that means conversation. So if I have a conversation taking place between, say, this host and somewhere out in the internet out here, what I'm really saying is I want to treat all the packets that are part of that conversation the same way. So I need to have a way to identify all those packets. We do that with something that in the geeky literature we talk about that called a five-tuple. A tuple is just a mathematical term that means group of thingies. It's just that mathematicians and computer scientists would feel stupid all the time talking about groups of thingies, so they call it a tuple instead. So what's the five group of thingies, the five tuple, that uniquely identify a conversation or a session? They are as follows. First, the source IP address, then the destination IP address, the source layer 4 port number, the destination layer 4 port number, and then lastly something called the layer 4 protocol number. So what is the layer 4 protocol number? Well, you remember in an IP header there's a field that's called the protocol field, and it contains a number that tells layer 3 what it's carrying at layer 4. So if the number is 1, it's ICMP. If the number is 6, it's TCP. If the number is 17, it's UDP. If the number is 47, it's the generic routing encapsulation protocol, GRE. If the number is 50, it's the encapsulating security protocol from IPsec for VPNs. So that number becomes the fifth item. Now these 5 items, when you take them client to server, and then the reverse direction, server to client, together they make up a session. Every session in a firewall receives a number, a session ID number. And so packets, when they're interpreted by the firewall, the first thing we do is say, is there an existing session here? And if so, what is it? And if I've already determined it matches security policy rule 7, I don't have to rematch that. I make my matching at the beginning of the session, determine what security policy should be enforced, and continue on. That's also true for routing. It's true for a whole bunch of factors. Additionally, you'll remember from your study of logs on this box that logs are not written to we don't make a copy of the logs until and unless the session has completed. So sessions are pretty important. Now, I want to talk about interpreting debug output. So the first thing we're going to do is in the CLI, we're going to enter this command, diagnose debug flow filter. The reason we want to put a filter on there, debug is what debug is going to do is, as packets flow through the firewall into the CPU, everything the CPU does, and it does a lot of individual steps, but every time it does a step, it's basically going to say, oh look, I just did this. oh look, I just did this. Now what if your CPU was running at say 70% of capacity already? Well, entering debug is going to more than double that. And since you can't run a CPU at 150% of capacity, that something else is going to give. Something bad is going to happen. So to avoid that something bad happening, and believe me, if it's bad enough, this could be an RGE in your career, a resume generating event. So we don't want to just put an unlimited debug on the box. We want to say, just give me the debug output for a particular source IP address. So it would be diagnose, debug, flow, filter, and you might say SADDR. So that's, here we go, SADDR with maybe 10.1.1.1. And maybe you also only want things going to port 80. So you enter that command. You now type again, diagnose, debug, flow, filter, but instead of saying SADDR, it's dport. You could have more lines, but we're going to stick with just those two. So what we're saying is run this debug only on packets with a source address of 10.1.1.1 destined for port 80. Then we type in diagnose, debug, enable, then diagnose, debug, flow, trace, start. And this is important. Another problem we have with debug is it's so verbose. It gives you so much information that it's easy for a screen to get away from you. When I used to teach Cisco CCNA, CCNP classes, I would teach my students to do a command call in Cisco called no debug all, undebug all, undebug all, and do that before you enter the debug command. So if the screen was so filled with output you couldn't figure out what you were typing, you just had to hit the up arrow key twice and hit enter. We can avoid that with a much more elegant solution in Fortinet by limiting the number of packets we're going to capture. Maybe it's 100, maybe it's 200, but we'll stop capturing at the end of those packets. And just as a matter of hygiene, we probably want to do diagnose, debug, flow, trace, stop, followed by a command diagnose, debug, flow, filter, clear. All right, we've run this command. Now we have some output. Let's take a look at and start interpreting that output. So some parts of this, I should mention, the slides we're looking at now have been taken from the Fortigate infrastructure class, module 8 on troubleshooting. So if you want to go back and look at the course material that references this, we've already put some boxes around certain things, but I'm going to take a few additional chunks of information. First of all, we see here that the VDOM root has received a packet. It is not uncommon. I can't tell you what I've seen on the test. I won't tell you that. It's both a violation of my NDA and bad for you. Companies want to see you have skills. Let me just step aside here from the course and say that the reason we don't want you just to have the answers to the test questions, a certification, it does what often a college degree does in this field and other fields. It gets you the interview. It does not get you the job. When you get to the job interview, no one cares what your certifications are. No hiring manager is saying, if only I had an NSE 8 certified employee. Or if they're saying that, what they really mean is, if only I had someone with the skills that this certification indicates. So you want to focus on getting the skills you need to pass that NSE 4, in this case, examination. All right. So now in the test though, the kind of questions they're going to ask to test you to see if you have the skills is they're often going to put several screenshots out there, call them exhibits. And they're going to test your knowledge by seeing, can you look at these exhibits, properly interpret them? There's a lot of red herring information in there. Doesn't apply to the question at all. And the real information you need might be an inference from something in an exhibit that you don't think is that important. Like, for instance, that this packet is going into the root VDOM. And there might be a lot of other information in there, and then the question might ask a certain, like, oh, I'm not even sure how to phrase it, but some question where the answers would not be valid if the distractor answers in the question might be the test VDOM is receiving the first packet in a SYN three-way handshake, receiving and you have to know that it's the root VDOM that's receiving the packet. Therefore, this nonsense answer about the test VDOM is not relevant. Okay. All right, so we care about that. Protocol 6, we just went through this, right? That means it's TCP. Here is the source socket. Socket's just a shorthand for IP address and port. Here's the source socket, 10.0.1.10, 49886. Where's it going? Here's the destination socket, 66, 171, 121, 44, port 80. From port 3, if I was king, which would be a frightening thought, one of the things I'd do, or CEO of Fortinet, even a more frightening thought, is I would make us use a different word than port for our interfaces, because we have logical ports at layer 4. This is talking about the physical interface. We came in interface 3. Now, the flag, it says S. There are actually 3 possibilities here. S equals SYN. That means it's a TCP SYN packet. Dot equals ACK. So if you saw just a dot, it would be an ACK. S dot, you guessed it, is SYN ACK. So this is a SYN packet. Here's the sequence number, acknowledgement number, window size. And because it's a SYN packet, it's the first packet in a session. And so we've created a new session. That's the session ID number that'll go into the session table. Now, when we're routing, we don't consult the routing table for every packet either. We look at the first packet that's going client to server and the first packet that's going server to client. And we look up those routes, and then we attach those routes to the session table so we don't have to consult the routing table again for this session unless there's a reconvergence of the routing table or something like that. So what we're saying here is I found a matching route, and now it doesn't say this here, but I'll now take that route and I'll write it or append it to the session table. So we know this session ID 00007FC0, that session ID uses this route. Then we find out that it is allowed by policy 1. You remember your policy number, your policies have numbers. They're not based on the sequence. Policy 1 theoretically could be the 7th or 8th policy down in your rule base, but it's policy number 1, and we're doing source NAT. And here's our source NAT address. We're going from 10.0.1.10 to 10.200.1.1. Notice, of course, the port number stays the same. We'll put that into a table so that we can translate the response back to the original IP address. Speaking of response, again, here is the VDOM received, VDOM root received a packet. It's still protocol 6. Here is the source address. Remember, that's coming from the external server. It's this source address, port 80. Its destination to the NATed address, 10.200.1.1, 49886. It's coming into us on port number 1, interface port number 1. There's that SYN ACK, the S for the SYN, the period for the ACK, sequence, acknowledgement, window size. We didn't create a new session because we found an existing session. We are doing destination NAT. You'll see that here. Here's this address, 10.200.1.1, 49886, and it's being translated back to the original IP address of 10.0.1.10, our internal address with the same port number. Again, we find a route. Why? Because this is the first packet going from server to client. We won't be looking, if you were to continue to see debug statements here, you would not subsequently see routes being looked up, only on the first two packets. Client to server, server to client. And that's it. So I hope you found this helpful. If you did, let me know. If you didn't, let me know. And if you have some other topics you'd like to cover, please let me know. I'll try to drop these, once or twice a week. Good luck, and I look forward to seeing you in some future live event sometime.